right, so I want to go back to what we were doing on Monday. Monday, we learned about independent and dependent probabilities. So I want to focus specifically on the dependent now, since we spent the last 2 days just doing independent. Okay, so these dependent probabilities, you have to watch out for the second fraction because we are not putting things back. So if you're not putting things back, your denominator is not the grand total anymore. All right, so let me do a few of these with you. Here we go. What is the probability that the first two cards drawn are face cards? And remember, you're not putting the first card back. Face cards, if you're not into cards, cards that have faces are your jack, your queen, and your king. And they come in diamonds, hearts, clubs, and spades. I can't draw. Here we go. All right. So there's 4 of these, and there's 4 of these, and there's 4 of these. So there's 12 face cards in a deck. All right. So we reach in. We hope to draw a face card. So we have 12 and 52 chance of getting a face card. After we take that first card, we keep it out, right? We do not put it back. So now we only have 51 cards in the deck. And theoretically, the first selection was a face card. So theoretically, we're now down to 11 face cards. Did it really happen? We don't know. All right, these are all theoretical. Okay, so calculator time. We've got 12 out of 52 times 11 out of 51, which is, ta-da, 0.05. So there's a 5% chance. I wouldn't put my money on it. What is the probability that all 3 cards are hearts? Okay, there are 13 hearts in a deck. You've got 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. We're going to draw 3 cards without replacement. So when we first reach into the deck of cards, there's 13 hearts out of 52. We take that card and we put it on the side. Now we're down to 51. Theoretically, the first card was a heart. So now we're down to 12 hearts. So that second card is taken out of the stack and we put it on the side. Now we're down to 50 cards. And again, theoretically, we picked a heart here and we picked a heart here. So now we're down to 11 hearts for this option. So let's multiply those together to see what the probability is. So we have 13 out of 52 times 12 out of 51 times 11 out of 50, and we get 0.01. Definitely don't put your money on that bet. Highly unlikely to get 3 hearts in a row. Part C. What is the probability all 3 cards are a king? There are 4 kings in a deck of cards. So you have the king of hearts, king of clubs, king of diamonds, king of spades. So we have a 4 in 52 chance. All right. Then we reach in and there's only 51 cards and we're down to 3 kings. Then we reach in, we have 50 cards left and only 2 kings, right? Because these are all without replacement. So it's going to decrease each time you go and you draw a card. All right, grab those calculators. Here we go. 4 out of 52 times 3 out of 51 times 2 out of 50, and voila, you get 0.0018. Oh my. So I'll say 0.0002. Next one, D-Dog. What is the probability that the first card is black and the second card is a 2? Okay, well, just like, well, we didn't do any red cards, did we? Okay, so the black cards are the clubs and the spades, so it's half of the deck. Half of 52 is 26, right? Yeah. So we have 26 black cards out of 52. All right. And then we're going to try and draw a 2. We have a 2 of hearts, we have the 2 of diamonds, we have the 2 of clubs, and we have the 2 of spades. So there's 4 of them. But how many cards are in the deck now? Remember, this first drawing was for a black card. We don't know necessarily if it was black, but now we're down to 51. All right. So we've got 26 out of 52 times 4 out of 51. And we get, oh, you know, I was just looking at it. Yeah, we'll just roll with it. My thought was we might have to subtract out the black 2 cards, but that would get into a deeper probability that you haven't quite done yet. So we'll keep it simple. All right, next up, a bag contains 4 blue and 4 red and 4 green. So there's 12 total, right? 12 total marbles. All right. What is the probability of drawing 2 green marbles without replacement? Lovely. All right, so a green, we have a 4 and 12. And then we go and we try again, but we're not replacing the first marble back. So we're down to 11 and 3. All right, so 4 divided by 12 times 3 divided by 11 is 0.09. All right, what is the probability of drawing 3 marbles without replacement in a row of the same color? Oh, this is going to be interesting because we have different combinations now that we have to worry about. Okay, so it could be red, or we could have all green, or we could have all blue. So or is bringing back some old probabilities that we did last week. Or means add. All right, so we want 3 reds. There's 1, 2, 3, 4 out of 12. Then we reach in and we try and get another one, but we're down 1. And we try and get another one. So there is your 3 reds. Or we could have 3 greens. Luckily, it's the same numbers, right? 4, 4, 4. So these fractions are pretty repetitive. So we have a 4 and 12 shot. 3, 11, 2, 10. Same for blue. 4, 12, 3, 11, 2, 10. All right, so let me grab the old calculator to figure out what this decimal is. We have 4 twelfths times 3 11ths times 2 tenths. So that's getting 3 in a row of the same color without replacement. And so that's 0.018181818181, and that's going to be the same decimal here and the same decimal here. So I'm going to go ahead and multiply this by 3. All right, we got 3 of those. So our probability total is 0.05. So there's a 5% chance of getting 3 of the same color in a row. Not bad, not bad. All right, James has 3 dimes, 4 pennies, and 2 quarters in his pocket. If each coin is equally likely to be pulled out of his pocket in order without replacement, what is the probability that he will pull out the 2 quarters in a row first? All right, so we want to pull out a quarter, and then another quarter. Alrighty, so we have 2 quarters out of 3, 4, 5, 6, 7, 8, 9. So there's 9 coins in his pocket. And means multiply without replacement, so we're down to 8. And there's only 1 quarter left because we assume this first event happened. Alright, so 2 ninths times 1/8. Ooh, calculator didn't like that. Is 0.027777. So I'm going to say 0.03. Alrighty. A cookie jar. There are 10 chocolate chip cookies and 8 peanut butter cookies. The cookies are randomly mixed together in the jar. What's the probability of pulling out a chocolate chip cookie? So chocolate chip. You eat it, and then you pull out a peanut butter cookie. Peanut butter. All right, so chocolate chip, there's 10 of them out of 18 total cookies. And means multiply, right? So when I see that popping in there, I'm going to be multiplying. Peanut butter. There's 8 peanut butter, but we ate one of the chocolate chips. So we're down to 17 cookies now. Notice the 8 didn't decrease because it's not the peanut butter that we ate, it was the chocolate chip that we ate. Okay, so we've got 10 out of 18 times 8 out of 17, and you get 0.26. Alrighty. Next up, in a classroom there are 7 male students and 11 female students that are taking a test. If each student is equally likely to turn in their test at any given time at the end of class, what's the probability that the first 3 students are females? Alright, so we want a female, and then another female, and then another female. So, 11 females out of 18 students. The first female already turned in her test, so now we're down to 10 out of 17. And now we're down to 9 out of 16. So we've got 11 out of 18 times 10 out of 17 times 9 out of 16. And you get 0.2022, so I'll just say 0.2. So there you have it. Take a picture, send it my way, and enjoy your afternoon.